Hello again, everybody, and welcome to video 4 in our right triangle trigonometry series. Today we're going to stick with sine and cosine ratio, but now we're going to look at lengths. Before we get moving into examples, let's do a quick review of the sine and cosine ratios. Sine ratio is when you compare the opposite leg with the hypotenuse, and cosine ratio is when you compare the adjacent leg with the hypotenuse. I said that one kind of funny, hypotenuse. Anyway, let's get working. So example 1, determine the measure of the missing side lengths. This is going to be just like as if we were finding side lengths with the tangent ratio. So again, just like the previous video, once we set this question up, we really don't have anything new. You already know this process. Okay, so we're looking for BC. So BC is right here, just so we can kind of highlight that. And again, we always have to start with an angle, so you need to kind of nail down what angle you're working from. And the reason we do that, reminder, is that once you have the angle picked out, then you can start naming things. So I can see this is right beside, so this means adjacent. Because remember, across means opposite. And then whatever is across from the right angle sign is always your hypotenuse. So you can see here that I've been given my hypotenuse, and I'm looking for the adjacent. So what has adjacent hypotenuse in it? Well, cosine does. So I'll use the cosine ratio to determine that missing length, BC. So cosine from the angle we're working with, which is 50. So, if I wanted, I could write cos theta equals the adjacent over the hypotenuse, but now I've replaced the theta with 50. So that theta is really a placeholder for your angle, and now we have an angle, so I threw that in there. The adjacent, we don't know, so we'll throw an x in, and then the hypotenuse is 5.2. So I'm not sure if you remember what we do from here, but once we get into this stage, it is simply a proportion. So we're just going to put this over 1. Remember, cos 50 is a value. Like that would be a decimal value if you plug that into your calculator, so really it's just a number. So we just have a proportion. So now I'm just going to solve like I'd solve any proportion. I always bring my my variable to the left side, so it's 1 times x, which is going to be equal to 5.2 times cos 50. Now remember, I could have wrote cos 50 times 5.2. The order doesn't matter. 1 times x is x. And when I multiply 5.2 times cos 50, I'll get 3.34. And then what is my unit? Looks like it's centimeters. Again, make sure you have your calculator figured out. Make sure it's in degrees and make sure you know how to type things in. If you don't, get talking to me so we can figure that out, because that's really frustrating for a student when they don't know how to use their calculator. Okay, B, we're looking for this missing side length of PQ, so that is right here. Again, we always start with nailing down our angle. So there's my angle that I'm working from. Now that I know that, that would have to be the opposite. And then I can see here right away, this is my hypotenuse because it's across from that right angle. Right beside would be my adjacent, but I don't have the adjacent. So you can see again, I have my I have an opposite, and I've been working with, I don't have the opposite. I'm looking for the opposite, and I have the hypotenuse. So which ratio deals with opposite and hypotenuse? Sine does. So I'll be using the sine ratio. So sine theta is equal to the opposite over the height. That's what I could write down if I like to, for memory trick or whatever. Now, instead of theta, I know it's 67 degrees. The opposite we talked about, I don't know. The hypotenuse, I do know, it's 10.4. Put the left side over 1. I have my proportion, so now I'll just cross multiply to solve. So setting up the ratio is really all the work. After you set it up, I don't think solving this proportion is very tough for you guys. Just got to make sure that you don't lose focus and maybe punch something in wrong or any other little like kind of really easy math errors that we can make. Anyway, 10.4 times sine 67 will give you 9.57. And do I have a unit? I do. It's centimeters again. Once again, make sure you are in degrees and not in something called radians. Third example, looking for DE. DE is right there. Okay, so now I know what I'm looking for. Identify the angle that you've been given. Now once you identify the angle, let's start naming things. So this is across the triangle, so that is opposite. This is across from my right angle, so that's my hypotenuse. So opposite and hypotenuse, sine. So we're going to use sine again. So sine of angle 55 is equal to 6.8 over x. So now this one's a little bit different than the previous question because now the unknown side, the variable, is in the bottom of my fraction in the denominator. Really, it doesn't matter. I'm pointing it out because it is different, but it's not any harder. It is one more step, but you're going to see that's not a difficult step. So I'll make my left side into a fraction, put it over 1, and I will cross multiply. I always bring my variable to the left side, so now I'll have x times sine 55. Once again, sine 55 is a value. You could type that into your calculator and see it, and you could write it as that value. I see sometimes students will do that. They'll turn sine 55 into the decimal value right away. I wouldn't do that. Leave it as sine 55 because that's a nice, easy way to write that out, and then I haven't had to round anything. It's a long decimal, the value for sine 55. So if you're going to write that in the question, you're likely not going to write 8 decimal points. You're likely going to get lazy and write 4. And then you're rounding, and now your answer might be slightly off. So leave it as sine 55. That's all I'm trying to say. Get back to solving, Mr. Troy. Okay, now multiplying the other way, 1 times 6.8. Now again, and you might remember this from the tangent video, we want x by itself. So to get something by itself, that means we have to move the other things around it. So I have to move that sine 55. The way you move something to the opposite side is by performing the opposite operation. The opposite operation would be division, because right now it's x times sine 55. So I have to divide to move the sine 55. And whatever you do to one side, you have to do the other side. So then x is going to be equal to 6.8 divided by sine 55. And that'll work out to 8.30. And again, we're dealing with centimeters. That was kind of a poor 8. There's a little bit better 8. But the big thing here is just that you'll have to divide. When the variable's on the bottom, you have to divide. It's one extra step. It's not difficult, but it is different. D, JK, that's JK, that's what I'm looking for right there. There's my X. Lock down the angle I'm dealing with. There it is. Now I name or label my side, so that would make this guy the adjacent. And again, this would be the hypotenuse. Adjacent and hypotenuse, that is cosine. So cos from this angle of 65 degrees. So we're having this comparison relative to this angle we're working with is 65 degrees. The adjacent is 4.7. Hypotenuse we're not sure about. We're wondering about it. So that's x. So put it over 1, start multiplying. And now I have to divide by cos 65. Sorry, I kind of went quiet there as I was writing this. So now it's going to be 4.7 divided by cos 65. Again, the reason I divided cos 65 is because I want the x by itself. Anyway, once I do that, I would get 11.12, and surprise, surprise, we're dealing with centimeters again. So that is really how we work through finding lengths for sine and cosine. The variable is going to be on the top or bottom, so there's only kind of 2 different patterns you need to know, and I've shown you both. So we have one final example. Again, it's a situational problem, so it doesn't have a picture, and you don't technically need to draw a picture. Some of you guys can kind of picture this in your mind, and that's good enough. But I'm going to draw a picture, and I definitely suggest drawing a picture. I think that's nice to have a visual. I'm a visual learner, though, so I like having visuals. Anyway, like we talked about in the previous video, we're always dealing with right triangles. So once I read this, I'm going to draw some sort of right triangle and then try to make it work with the situation. So let's read. Sam and Sophia are building a wooden ramp for skateboarding. The height of the ramp is 0.75 meters. The ramp makes an angle of 8 degrees with the ground. What length of plywood does Sam and Sophia need for the top of the ramp? Determine the length to the nearest tenth of a meter. So I got to remember the rounding. Sometimes I forget the rounding in my videos, I've noticed. Anyway, okay, so I got a skateboard ramp. So not that I've used a ton of ramps in my days, but that's a very typical ramp that you'd maybe build on your street to take your bike off or your skateboard. So it said the height of the ramp is 0.75 meters. So the height of the ramp, 0.75. Remember that height's always a vertical measurement. So that's that vertical line there. And again, like I've talked about in a previous video, we're always assuming our ground is level in all these questions. If it's not, they'll tell you. So when you have a horizontal line meeting a vertical line, you always have a 90-degree angle. And again, they will tell you if the ground is slanted somewhat. So it's always flat horizontal until they say otherwise. Moving on. So we've got this 0.75 in. The ramp makes an angle of 8 degrees with the ground. So this would be the ground. This would be the ramp, or the rampy part of the ramp. So that would mean this would be 8 degrees here. So what length of plywood does Sam and Sophia need for the top of the ramp? So the top would be this part. If you're kind of wondering, the actual ramp part of the ramp. And this part over here, I guess you'd call that some sort of support for the ramp. And we want to know how long it is to the nearest tenth of a meter. Okay, so once I've drawn it, now I want to make sure, okay, so this is the angle I'm working from, so now we'll name things. Well, that makes this the opposite, and that would make this the hypotenuse, so I'm going to deal with sine. So sine of 8 degrees equals 0.75 over x. So the variable's on the bottom, so it's that one step longer procedure, which isn't a big deal. So I'm cross-multiplying. I always bring that variable to my left side, and why I do that is because really we want to always finish with your variable on the left side. So knowing I want my variable on the left side in the end, I use that fact at the start, and I bring it to the left side at the start, so I can kind of forget about that fact. I've already done it. 1 times 0.75 is 0.75, and I want the x by itself, so I have to divide by sine 8. What I do to one side of the equation, I must do the other side. Sine 8 divided by sine 8 does not equal 0. That's not why I'm crossing it out, reminder. That is equivalent to 1, because it's the sum value divided by itself is always equal to 1, and then we can choose not to write it, because really anything times 1 is that anything. So x times 1 is just x, so I can just leave it as x. Just a quick reminder of what that means when I cross it out like that. Anyway, 0.75 divided by sine 8 works out to be 5.39 is what I wrote it down to, and then we have to round it to the nearest tenth of a meter. So 5.4 meters would be my answer. Okay, and that is how you find length using the sine and cosine ratio. Once again, I think the solving likely is pretty darn easy for you guys. It's just making sure you set things up right and making sure that you're using your calculator properly. So if you are having issues, make sure you talk to your teacher or come find myself. Have a great night, everybody.